I am a professor of urbanism and disaster risk reduction in the Bartlett, and part of this UNESCO chair. I'm the first time hosting one of these webinars this week, having joined the chair a few months ago, part of the team. So very happy to be here. We're joined today by Iqbal Hussain from the BGS, who's going to talk to us about some of his research, and I'll do a little intro. And we also have our three lovely research fellows who are part of the UNESCO chair and have organized the session here. So just to share my screen, today's talk is natural hazards and unnatural disasters. Oops, sorry. The anatomy of risk in a dynamic world. And Iqbal was going to probably speak for maybe the first hour, and then we'll have discussion afterwards. So please put your questions onto the chat or the Q&A so we can address them later, and hopefully we can have a very good discussion. Just before we start, I'd like to just highlight that we have a couple of other webinars coming up, one on disaster impacts beyond direct damage, assessing first and second order indirect impacts, and this will be on the 10th of March. And then on the 31st of March, we're looking at intelligent tropical storm resilient system for coastal cities in a changing climate. And on the 21st of April, towards resilient cities through digital coupled human nature and infrastructure systems. So talking about this project Chains. So we look forward to hopefully seeing you there for those. Just to introduce Dr. Iqbal Hussain, he's a multi-hazards and remote sensing geoscientist at the British Geological Survey. As we're going to see today, his research uses satellite data to understand natural and anthropogenic hazards, earthquakes, landslides, and subsidence. He's worked in Indonesia, in Turkey, Ethiopia, Vietnam. I think he's going to talk about those. And he also works with, beyond science, works with stakeholders to understand and manage disaster risk. And has been working in Indonesia. He was just talking to me a bit about that before the webinar, so I think he'll talk about that. And he's also the PI for the UK sponsorship of the Global Earthquake Model of the GEM, and he's also a member of the NERC Science and Innovation Advisory Committee, helping to advise NERC on strategic priorities for science funding. So if you have any ideas on those, maybe you can ask him in the Q&A. Okay. So that's it from me. Thank you so much, Dr. Hussain. I will stop sharing and leave it over to you.
Thank you very much. So I'll just start sharing and I can get started. Right, please can you just check if you can see my slides?
Yes.
Great, brilliant. So thank you. Yeah, great. Thank you all. Thanks very much, everyone. So it's great to be here and it's great to be invited to give this talk. And it's actually a talk a little bit, I'm not won't do too much of satellite remote sensing because although that is my bread and butter, but I'll talk a little bit about why and how natural hazards turn into disasters. And it's a topic I've been thinking about for a number of years now, and sort of coalescing some of their thoughts into a few slides here. And just before I start, I'm going to talk about one particular hazard that I know very well, earthquakes, but the themes that I want to talk about, I will talk about today, apply to all hazards, whether natural or anthropogenic. So please do think about, as I'm talking through this 45-minute hour or so, how the elements of what I'm saying are relevant for earthquakes, tsunamis, landslides, financial crises, technological collapse, etc. So they are relevant, and it'd be great to have a conversation on how they become relevant. So to start with, earthquakes, and I'll demonstrate some of these themes. I'll go in and out of Turkey and the world, but Turkey is a country I know quite well, and I've done a lot of work there. And to introduce Turkey and the geodynamics of Turkey, here is the GPS velocity field for Turkey and Greece and the surrounding region, and it shows this really beautiful anti-clockwise rotation around. I think the pole is in Egypt, but this is also driven by two big forces: the Arabian stiff concentric crust punching north into Asia by around 15 millimeters per year, and the Hellenic subduction zone pulling Anatolia in the west. And these two forces act, and the entirety of Anatolia rotates along these two major structures. On the north Anatolian fault, in the east, southeast, the East Anatolian fault. So that's the broad geodynamic picture of Turkey. And to quickly zoom into North Anatolian fault, it's a fault that I did my PhD on. And this fault has had a series of large earthquakes over the last century or so. And it all began with this big earthquake in 1939, a magnitude 7.8, that killed around 30,000 people. A few years after that, a 6.9, just further to the west of that rupture. A year after that, another large 7.7 in 1943. In 1944, a year again, and a 6.8. And then there was a 10-year hiatus, a break, and in 1957, there was another big earthquake, a 6.8 further west of that again, and another 10-year break, and then a magnitude 7, and then a few decades break, and two large magnitude 7s here. So, and then there were other small earthquakes in between. And it doesn't take a genius to spot the pattern here. The earthquakes are going from the west to the east, the earthquake progression. And so this is a pattern we've known for a long time now. And if you were to guess, do a prediction of where you think the next big earthquake would be, you'd guess around here in the Marmara Sea to the west of the last earthquake, and which is where you have Istanbul, one of the largest cities in the world, around 15 million people, and that's the place we're keeping our eye on for this potential big earthquake that could lead to a disaster of sort of significant proportions. So what happened in February 2023? There was two very big earthquakes here on the eastern Anatolian fault, where we kept our eyes off the mark for a while, but that caught us out. It was a surprise, and this is what happened in that earthquake. Two big earthquakes, one 7.8 at 4:17 in the morning. That timing is important. I'll come back to that later on why. And 9 hours later at 1 p.m., a magnitude 7.5 further to the north. And, this is what happened, the sort of devastation and destruction that you see in these major type big earthquakes. And so it's the high level numbers, what happened there. So around 60,000 people died, to 62 possibly, in Turkey and northern Syria. Population of some of these towns, Kahramanmaraş, Hatay, and Adiyaman, were devastated, potentially impacted by about half all the population were lost. Nearly 250,000 buildings were damaged or collapsed, and will have to be rebuilt or redesigned. And immediate estimated economic losses of around 150, 160 billion US dollars. And that was the immediate damage economic assessment. I mean, obviously it's been 2 years. There have been ongoing economic challenges since then. So by every measure, a disaster, by every definition. And so what did we do as an Earth observation community? We immediately started tasking satellites to collect satellite information. Here's through our colleagues at the Center for the Observation and Monitoring of Earthquakes, Volcanoes, and Tectonics, COMET, a mouthful. They produced this satellite radar map of the ground deformation. So every ring here, it shows you around 2.3 centimeters of ground motion. So all you would do is count all the rings, including all the sort of aliased ones in the middle, to estimate how much the ground had moved in that earthquake. We could also make maps like this where pixel offsets, where we look at an image before and an image after and try and track every rock and stone and how far it's moved in that earthquake. And you can see the fault lines come up really beautifully in this type of images. And these types of images were produced within a couple of days of the earthquake, and they really helped us to target where the field investigations had to be done to understand the sort of where the rupture had happened and the potential consequences of it. So that's what we could do immediately with satellite data. Once we have this data, we can start then doing modeling, and we can we can do this anywhere in the world. We can do some modeling, and this is a sort of a slip-in version. So looking onto the fault of that main 7.8 earthquake, and you can see where along the fault that energy or slip was released. So red colors indicate where the fault moved a lot and released a lot of stored energy, and bluer colors where it didn't. So in general, this big fault, by the way, ruptured around something on the order of 300 odd kilometers, and in general, most of it released energy. There's sort of reddy yellow colors along most of the length of that fault, and then it stopped around here. And so this bit here did not release the energy. So if I were in the sort of prediction business and I was asked, where do you think the next earthquake could happen on this fault? I'd have said there. And in fact, a year later, this is where another magnitude 6.6 odd earthquake happened and filled in that gap. So this kind of detailed modeling can help us understand where earthquake strain energy was released, and also importantly, where it was not released and where there's potential for a future earthquake. So that's the coseismic, the in earthquake period. What about the period before the earthquake? That whole period that could be from decades to centuries to millennia of energy storage, any energy accumulation on that fault. And we can do some work on that too. So this is an INSAR map. So it's lots of satellite radar images that have been collected together, and you look at how the piece of ground has moved between all of those images. So you can build up a time series of ground motion. And this is the average of all of those deformation. And red colors here show motion to the west, and blue colors show motion to the east. And you can see the two big fault lines, the North Antonian fault, coming out quite nicely here between the red and the blue transition, and less clearly the red to yellow transition on the East Antonian fault. So what this tells us is where the energy is getting stored on the fault, where that strain accumulation is occurring, and all of that strain must be released somehow. Whether it's in an earthquake or other aseismic processes, it must be released. So this gives us an idea where it's dangerous, where the energy accumulation is occurring. So we can measure how much energy is getting stored on this fault that will need to be released. So and we can calculate, if all the energy was released now, how big the earthquake could be. And then we could do these profiles like this. You don't have to use INSAR, you could use GPS measurements. You can then do scenarios. So think about that fault line, and it has accumulated this much strain. And if it were to be released now, it could produce a certain size earthquake, could be a 6, could be a 7. This is an example from Indonesia. And you could simulate the shaking intensities from that earthquake. And then if you have information about the buildings and the people, you can start estimating losses. This is the sort of bread and butter of the catastrophe industry, catastrophe risk management industry. So knowing all of this information about the strain, the seismic history, helps us develop better hazard products. And combining all of that information together, particularly the historical seismicity, you can create maps like this. So this is the seismic hazard map for Turkey. This was created before those earthquakes in 2018. And red colors represent here high seismic hazard, and paler colors low seismic hazard. And you can see quite nicely the two main structures, North Antonian fault and the East Antonian faults, cropping alongside this extension zone in the west. And so again, and in blue here are the two big earthquakes that happened last year. So the location of these earthquakes was not a surprise. They were known to be highly seismic, and the hazard was high, and so the location wasn't a huge surprise to those of us in the seismic hazard world. But yet 60,000 people died. So if the location wasn't a surprise and the potential magnitudes weren't a surprise, how did 60,000 people die? So knowing the hazard is not enough to manage disaster risk. So just being a geophysicist or a geological engineer isn't enough to manage disaster risk. And that's the core thesis of what I'm trying to say today. And for the rest of this talk, I'll go over the sort of why and how natural hazards become risk disasters. But to do that, we'll step out a bit and look at a global perspective. On here are all the major earthquakes in the last 100 years or so that have killed some people. And on the bottom, we have the earthquake magnitude, and on the left, on the y-axis, we have the fatalities. So let's make a simple assumption. Big earthquakes kill more people. And in general, there's sort of a positive trend on this graph showing bigger earthquakes tend to have high fatality rates. But is it so simple? And I'll demonstrate that with a few examples. This is the Turkey earthquake in 2023. It was a magnitude 7.8 earthquake, killed around 60,000 people. This is the largest earthquake we've ever measured, a 9.5 in Chile, 1960. That killed around 2,000 to 3,000 people. So that's still a lot of people. But if you were to follow this chart, the death rate should have been up to around million, but it wasn't, thankfully. This is the Haiti earthquake, possibly the most deadly earthquake that's happened in the last few decades. A magnitude 7.1 in Haiti killed around anything from 100,000 to 300,000 people, depending on which source you look at. And the year after that, a 7.1 earthquake in Pakistan, the Dalbandin earthquake, killed around 5 people. So the same size earthquake in Haiti, year before, killed up to 300,000 people. And the year after, the same size earthquake killed 5 people. So clearly there's more to this story than just size. It's not just size that matters. And to start off, I'll give you the answers. I'll tell you how and why I think natural hazards become disasters. It's because of these 4 things: exposure, vulnerability, corruption, and ignorance. What do I mean by that? Exposure simply is where and what are the things that we care about. Vulnerability is how fragile are the things that we care about. Corruption is how enforced are the safety rules. We're not even questioning the existence of the rules, because almost every country in the world has regulation and rules on how things should be done. It's corruption is how well enforced are they. Ignorance is do people even know what the rules are, what the regulations are? And I'll go over each one of these in a little bit of detail over the next few minutes. And before I can move on, because I couldn't resist the temptation, I've called these the 4 horsemen of disaster risk. So these are my 4 horsemen, and I'll go through each one next. So exposure, what do we mean by that in the context of earthquakes? In the context of earthquakes, exposure means where do people live and what sort of buildings do they live in? So that's a question of 2 parts. And the first part is quite easy. Where do people live? Because almost every country in the world has a census survey, and it maps very accurately where everyone lives in their own country. And we can supplement that information with satellite data and other bits of information to make a map of the world's population. And this is it. This is the world's population, where they are. And there are obvious patterns here where most of the world is empty, for one. And there are large parts of the world where there's hugely dense groups of people from, especially this zone from Europe to the Middle East, South Asia, and East Asia. There's a concentration of people there, and that matters when it comes to exposure. The second part is harder. What sort of buildings do people live in? Because it clearly matters if you live in an earthquake, if you live in the building on the top versus living in the building on the bottom. And this is sort of something we've all in the UK and we learned since we were kids, like the 3 Beligos graph, right? The wood house, the straw house, and the brick house. We understand intuitively the vulnerability of structural buildings, and it's not so dissimilar. But to do this, we need to do an engineering survey of every building in the world, which is practically impossible because there are hundreds of millions to billions of buildings, and we can't do an engineering survey of all of them. So we now have to do some sort of tricks and aggregation tricks. We can start doing using AI, trying to map where every building is in the world, and trying to sort of estimate their building types and their sort of structural vulnerabilities when it comes to shaking. This is something we did. So we did this for all the least developed countries in the world through a project funded by the UK Space Agency. And we produced the data set, which is available on this website at a 500, and then we aggregated all these buildings to a 500 meter to grid. And we released this exposure model for all the least developed countries. So it's free and open access. So feel free to access that website and use those vulnerability functions. Those exposure models and the associated vulnerability functions. But please let us know if you do use it. But this still remains one of the big problems. We can't do a building by building assessment, and it is currently one of the biggest barriers to doing bespoke seismic hazard assessments. And moving on. So this is a particularly old figure. So apologies for the graininess, but it's a nice figure, and it shows where all the fatal earthquakes have happened in the last 1,000 years or so. And the bigger the square, the more fatal some of these earthquakes have been. And in yellow here are the subduction zones, where we tend to get the largest earthquakes. So one plate is pushed underneath another. You have a huge surface area where strain can accumulate, and when all of that strain gets released, they produce the big 9s, big 8s, and the tsunamigenic earthquakes that we've seen in the news a lot. So the yellow is where you get the big earthquakes, but red is where you get the most fatal events. In fact, something like 85% of all the world's fatal earthquakes in the past 1,000 years happened in the red oval circle. So away from where you get the largest earthquakes. So some countries have much higher exposure to earthquakes than others. And it's interesting, I don't have time to go into why this is the case. It's partly because of that's where most people live. If you split out those earthquakes into a graph form, so here are the subduction zone earthquakes, the really big ones, i.e. the big 9s. This is missing this is from 2011, so it's a little bit old. But it shows all the fatal earthquakes. So up to then, there are 2 big 9s that killed around 250,000 people each. So 6 magnitude 8s that killed again 250,000 people. And these are all this is what we call continental earthquakes in the red circle, i.e., so these are smaller. They tend to be between 6 and 7 or 7 and 8 magnitudes, and they tend to be more fatal. So 20 magnitude 7.5 killed around 600,000 people in the last century or so. So to summarize, the most fatal earthquakes occur between magnitude 7 to 8 in the continental interiors, historically. So that's exposure. Vulnerability is second horseman. And this is defined as the physical or social conditions that increase the susceptibility to hazards. And this is again a horseman of two parts: a social and physical vulnerability. Let's look at this graph first. This is my favorite graph of all time, and I wish everyone knew it. And I'll go through it step by step. It's clearly the population growth in the last 200 years or so. In 1820, there was 1 billion people, and now it's around just over 8 billion people in the world. And this growth is not a surprise to anyone, I hope. This red zone is the number of people who have lived in extreme poverty. And this is a well-defined measure. Anyone who lives on less than 2.1 international dollars a day is living in extreme poverty. And this is just about enough money to feed yourself on a daily basis, just about enough to have a meal a day on a daily basis. So every single person in red here lived in extreme poverty and could not feed themselves, which was around 2 billion people in 1960, and started going down since then. But as a fraction of the total population, it shows this really, really dramatic and wonderful story that shows that in 1820, 80% of the world could not feed itself on a daily basis. And that number has more or less systematically been going down to around 700 million, or 9% of the world now. And this is one of the greatest news stories that I wish more people knew about. The fraction of people living in extreme poverty and the total number is decreasing very dramatically every year. So much so that all the world's media could have ran this headline: 115,000 people escaped from extreme poverty since yesterday. All the world's media could have ran that headline every single day for the past 35 years. That's how many people come out of extreme poverty. So that's a good thing, right? So why is it one of my horsemen of disaster risk? It's because extreme poverty looks like this. Those who are living in extreme poverty live in homes that are locally built with local materials, i.e. wood or bamboo or mud. And amazingly, these structures are quite resilient to earthquakes. Wood can absorb energy, and even if that house falls on you, the straw is unlikely to kill you. But when people come out of extreme poverty, all those 115,000 people a day, they're coming out of extreme poverty. And when people come out of extreme poverty, they do these 5 things, and they do it in this kind of order. And they send their kids to school, they vaccinate their children, they buy a mobile phone, they get electricity, and then they build their own homes. But remember, these are extremely poor people still. So they're not, inundated with cash. Almost all of these people build their own homes themselves. So 96% of all the poorest people who build homes build it themselves or through a family member. And this is how they do it. So this is a photo I took in Bangladesh. This family is moving out to this bamboo tin house in the background, and they're building a new home for themselves. And there are some structurally difficult things happening here. First, you notice the bricks. The bricks are side on like this. If you go outside and look at a construction site or you're in a building, the bricks are flat. And that's because there's more surface area of the brick with the ground, and therefore there's a stronger, stable wall. But building walls with flat bricks takes more bricks, and therefore it's more costly. And if you're poor, you can't afford that. So you try and build a wall with a few of the more bricks you can, and you put them side on, which fundamentally weakens that wall and the stability of that wall. Here's another example. Again, this family's moved out to this tin house on the left to this brick house on the right. Same problems here, the brick side on. The pillars are very narrow and thin. They probably don't have enough rebar rods in them. The strength of a house is in the pillars, and the strength of a pillar is in the number of rebar rods. And there's those metal rods you see. And every house these pillars should have at least 4 rods in them, and these don't. So in an earthquake, this family is probably going to be safer in the tin house on the left than in the brick house on the right. So what we say is the jump from extremely poor to just poor, remember, there's still a very poor people, often increases the risk to earthquake shaking because of this change in their household, in the house. So we need to accelerate people out of this dip into a more sustainable and resilient structures. And fundamentally, it's because of this famous adage from Nicholas Ambrosius that earthquakes don't kill people, buildings do. So that was physical vulnerability. How about social vulnerability? Let's go back to Turkey. Yeah. And so this is a map of the disposable income in Turkey by region. Red colors are areas where there's a high level of disposable income, i.e., there's wealthy people, and pale colors are where there are poorer people. And this blue line is a sort of quick sort of estimate of where that big earthquake happened. So in the 10 most affected areas in that earthquake, 1.5 million people lived below the national poverty line, i.e., poverty was concentrated down in that region. Here's a map of total fertility. This is an index that I'm particularly interested in, and I have an entire lecture on this. What we mean by total fertility is the number of children a family or a mother chooses to have, and that choice, on an average, global average, has very little to do with religion, race, ethnicity, geography, temperature. It has nothing to do with any of that. It only correlates with one measure, and that's poverty. Larger families, on a global average, are correlated with poverty. So if you find the large families, you find the poorest families. And here's a way of showing that. So the in red colors here are families where total fertility of where there are large families. I have children, a family or a mother is choosing to have more children, and which again is a proxy for poverty. Here in this area where the earthquake struck. And on top of that, 6.5 million refugees from the 10 years of civil war in Syria. And people generally don't own the land they live on or the property they live in. And they live in houses that are old or illegally built and in overcrowded conditions. So all of that together means they are more vulnerable. They are more vulnerable not just to earthquakes and hurricanes and tsunamis and typhoons and rainfall. They are more vulnerable to technological disaster. They are more vulnerable to financial crisis and any hazard you can think of. So if you find the poorest people, you will generally find the most vulnerable to almost all hazards. That's what we mean by social vulnerability. Corruption, the third horseman. To define this, what we mean by that is simple: the misuse of interested power of private gain. I've trusted you to do something, and you have abused that trust. And it's not a rocket science, or you don't need me to tell you that corruption is deadly. But what does corruption mean when it comes to earthquakes? And most of you are engineers here, so I don't want to simplify this too much. You all know this better than me. But those who aren't engineers, there's almost like a golden ratio for mixing, making strong mortar. You mix 3 bags sand, 1 bag cement, mix it with water, and you make your house with it. And that's the sort of what it's designed to do, to get a strong, solid mortar for your house. But if you're a corrupt contractor, what do? You mix 6 bags sand and 1 bag cement. Because cement is more expensive, you pocket the extra money, and you mix it with water. It looks the same, tastes the same, but it does not behave the same. Your house is fundamentally weakened because you've not followed the rules in how to make a good mortar. So that's what we mean by that, is sort of cutting corners, using insufficient building materials and bad practice. That's one form of corruption. Another form of corruption is building homes badly, not putting enough rebar rods, because once you've put it in the pillar, you can't tell, right? Especially if there's no inspections, and you can pocket the money on the rods that you didn't use. And putting buildings in bad places. This is a universal problem, not just in poor countries. You can just look outside, see how many homes you have on floodplains, and so that's the problem all over the world. And so I know some of you here in this webinar were part of the EFIT mission to Turkey following that earthquake. And what they did was they took rock cores, not of the rock, but of some of the pillars of some of these big buildings that collapsed in that earthquake. And what did they see? They found these giant pebbles in the cement mix in the pillars. And some aggregate is part of what you should do. Some round angular aggregates is a design feature, but big round pebbles are not what should be in the mortar mix for a big building. And those of you who are geologists know where big round pebbles come from. They come from rivers. And so what this contractor done was gone to the local river, picked up a load of stones and dropped it into the mortar mix to bulk out the cement. And this fundamentally weakens that cement and its ability to support load, and arguably contributed to the collapse of this building. Another thing you're meant to do in construction standards is use the rebar rods that go into the pillars have to have ridges on them, ribs. And what that does is increases the surface area of the rod with the cement. So remember, the strength of a pillar is in the rod. The more and that connection is enhanced, the stronger that whole pillar becomes. But ribbed rebar is more expensive than smooth rebar. So if you're a corrupt contractor, what do? You put the smooth one in the pillar, and don't tell anyone, and pocket the extra and the savings, But fundamentally, it weakens that pillar and its ability to hold the load, and again contributes to the failure of the building. So that's an example of what was happening in Southeast Turkey at the time. And it's not like Turkey didn't know what to do. Turkey does have a very good and detailed building code on how to build buildings, and this is regularly updated. The last update was 2018. It's being updated again, and so there's there's a very good plan on how to build buildings, but and here's a good example. The Department of Engineering in the Kahramanmaraş region. So clearly these guys know what to do, but enforcement is always the challenge, and this is again a problem all over the world. Here's a sales document for one of these big tower blocks that collapsed in that same area. And in Turkish, in the text here, it says, completing in compliance with the latest earthquake regulations. Clearly it wasn't because it collapsed, and the building contractors are in jail because they didn't follow the rules. But what if people did follow the rules? This is a story I read about following the earthquake, that in this town called Erzin, just south of Kahramanmaraş, just here, so Kahramanmaraş here, if you remember, this circle, this black circle, remember 50% of the population nearly died. Erzin is just further to the south here. Not that almost equidistant from the fault as Kahramanmaraş was. But in this case, no one died. Not a single building collapsed, no one died. There's a few structural issues. I think chimneys or equivalent fell over, but no one was injured. And some people attribute that to the mayor. The mayor was well known for not allowing illegal building practice, had lots of inspections and reporting mechanisms for buildings. So I'm not fully sure. I can't confirm if that's the case or not, but not a single building collapsed in this town. So maybe this is a contributing factor to that safety. Added on top of all of this in Turkey is this strange thing called imar barişi, which is a way, I think, of getting votes. It's a way of saying old buildings that were built illegally, if you pay us a fee, we'll give you a legal certificate for it. Nothing in that building has to change, and especially if you give us your vote, you just pay us a fine and we'll legalize your building. And in 2021, over 300,000 buildings across the 11 most affected provinces were legalized using this mechanism. So those buildings are not any safer than they were before that certificate was issued, but they now have a legal certificate saying that it's a safe building. And this is completely legal. This is what I would say legalized corruption. So how do you measure corruption? And this turns out to be really difficult. You can't just go to a country and say, how corrupt are you feeling from a scale of 0 to 10? It's a very difficult thing to measure. But these guys, Transparency International, have been trying to do this and been doing it for over 2 decades now. And they use various measures, which I don't have time to go into today, and to give every country in the world a score of from 0 to 100. 100 is a score of no corruption, where absolutely, Angel, no corruption at all. 0 is absolute and total corruption. And it won't surprise you to hear that the most corrupt nations in the world are countries like New Zealand and the Scandinavian nations. And the most corrupt countries in the world are South Sudan, Somalia, Syria, Afghanistan, countries like that. And why does this matter? Because these are the most fatal earthquakes in the last 2 decades or so. They're all in sort of orange and red countries. So if this is a scale of 0 to 100, you take the middle mark, 50. 50 is like neither fully corrupt or neither fully angelic. 50 middle guy. 2/3 of all countries in the world score below 50, meaning that they are more corrupt than not. 2/3 of all countries in the world are more corrupt than not. Why does that matter? It matters because the construction industry, the guys building your homes in those countries, are the most corrupt people in those economies. Actually, it's the world economy. So how do we visualize some of this corruption story? And this is a graph, a famous graph that from Nicholas Ambrasius and Roger Billam from 2012 that I had my students recreate using the latest data. And what it shows is every country in the world against with their national income, i.e. GNI, against their corruption score. Remember, high score is less corrupt and low score is more corrupt. And there seems to be this positive trend, which means that if you fall on the line, you're a country that is just as corrupt as we expect you to be. Countries like the United States, Britain, they fall on this line. If you fall above the line, you're less corrupt than we expected you to be, given your national income. Countries like Japan, New Zealand, Chile fall above the line. If you fall below the line, you're more corrupt than we expect you to be, given your national income. Countries like Italy, Russia, Mexico, Ecuador fall below the line. Probably not a surprise to some of you. So if I were to help us out here, those are the good guys, those are the bad guys, and this is where it's all gone wrong. Poverty, ignorance, corruption, it's all gone a little bit messy down there. And why is this a problem? It's a problem because 83% of all deaths in the last 30 years in earthquakes were in countries that are low income, so poor, and anomalously corrupt, i.e. in the red or the yellow zones. So corruption kills. Corruption clearly matters. Horseman number 4, ignorance. What do I mean by that? First, the ignorance of two parts. First is knowledge gaps. So this is about not knowing where the hazard is, i.e. not knowing where the faults are, how dangerous they can be. And this is the bread and butter of most of us who are working in geophysics. We spend a lot of our time trying to understand the world, trying to understand the hazard, trying to understand how dangerous are these faults, trying to find the new faults that could be dangerous. And this is knowledge gap. This is where science can really make a big difference in terms of fundamental research. The other type of knowledge gap that I think is more interesting to me is this. This is back to Turkey again. On the left, on top left, we have the number of graduates coming out of geological engineering degrees. And the bottom, the number of graduates coming out of geophysical engineering degrees. And the line shows that there's a long-term decline in the number of people coming out of those degrees, despite the fact that the number of civil engineering courses being high. So the number of people who know about your geophysical hazard, the problem, and how to design solutions against them is on a long-term decline in Turkey. And this is a fundamental long-term problem for managing risk. That ignorance gap is only growing. And that's not just a problem in Turkey, it's a problem in the United States, it's a problem here in the UK, and many of our Western nations. So this is what I mean by the ignorance in this context. So that's it. Those are the 4 horsemen. This is why an earthquake becomes a disaster because of these 4 horsemen. But the problem is the world is not just earthquakes. And this is part 2 of my talk. The world is more than just an earthquake. They have what we call these cascading hazards or multi-hazards. And a very simple one is an earthquake triggers tsunami, can trigger a tsunami, especially in the coast, if it's in the oceans. They can trigger landslides. Landslides can block rivers, and those rivers can flood. This is a simple multi-hazard cascade. Here's a good example of one of these. The 2011 Tohoku earthquake at magnitude 9.1 off the east coast of Japan generated a very large tsunami. Many of you will have seen the videos that came out of that. It also generated thousands of landslides. This particular landslide destroyed a dam that flooded a village down slope. And this tsunami, as you'll remember, famously led to a nuclear explosion, an explosion at the nuclear power plant. So this natural hazard cascade interacted and led to a man-made disaster as well. So this is what we call a multi-hazard event. So if we go back to Turkey, let's find what happened in Turkey in terms of the hours and weeks and months following that earthquake. We'll start with, I'm going to split the hazards up into geological and hydrometeorological hazards. So we start at 4:17 in the morning with a magnitude 7.8 earthquake. That triggered a small tsunami, I think about 14 centimeter tsunami off the southeast coast of Turkey, and led to some flooding. And 9 hours later, the second large earthquake. And both those earthquakes led to, as you would expect, months and months of quite significant aftershocks and thousands liquefaction and thousands of landslides. I think we mapped up to 25,000 landslides following that earthquake. And many of them were deadly. And so that's what happened within the first few hours, first few days of that event. But let's go back to that first earthquake. At 4:17 in the morning, what are most people doing at 4:17 in the morning? They are in bed. So when the world starts shaking, what do? You hide under the table, hold on to the table, drop, cover, hold, and until the shaking stops, and then you run outside. You don't have time to pack your bags. You run outside wearing whatever you were wearing in bed at 4:17 in the morning. So what did these people run outside to? They ran outside to this: heavy snow, snowstorm, strong winds, and extreme cold. In some parts of southeast Turkey at the time, the snow was a meter high. The temperatures were down to minus 19 degrees Celsius. That's what most people run outside to. And then obviously the snow melted, tsunami caused flooding. The snow melted, caused more flooding. Landslides will have caused more flooding later on. So all of this led to more sort of water available in the landscape. Fast forward a week now. Most people are now living in tents because they're not allowed in their homes. And outside in a tent is the last place you want to be when there's a severe storm and there's a flash flood with more flooding. And 20 people died in those floods the week after because they were in the tent, not in their homes. If they were in their homes, they would have been safe. Fast forward another couple of weeks, and there was another storm that led to more flash flooding, a heavy hail, and a tornado in that same area. When I say heavy hail, I don't mean the things that we get in the UK, the little small things. These were golf ball size hailstorms, hail. And again, you don't want to be in a tent when they start falling. Fast forward a few more weeks again, now we're in the summer. Most people have been upgraded from flimsy tents to metal shipping container. So much better, safer, more privacy. But last place you want to be when there's a 40 plus degree heat wave. And all of that happened within the first 6 months of that earthquake happening. So, and what were the impacts of it? Unsurprising, lots of building collapse, disabilities, fatalities, homelessness. We think we worry about the lives that were lost and often forget about the lives that were not lost. The disability issue that happens. Quite a number of people were disabled. And there's a huge psychosocial challenge following major disasters like this. Housing, of course, is a big problem. Not just the economic loss of individuals, their entire life savings could have been lost. And in this particular case, the regional geopolitics. So the Syria-Turkey relationships weren't particularly nice before the earthquake. Thankfully, this earthquake led to some sort of transfer of resources between those boundaries, but it could have made it worse. And disrupted education. Nearly 4 million children were not in school for at least 2.5 months. We know very well from childhood development studies the impact of a child missing a week of school is a measurable impact. A child missing 2.5 months of school, or 4 months of school, has a generational impact, and that's an impact is ongoing. So this is what happened in February the 6th, 2023. If this earthquake were to happen in February the 6th, 2053, all of these hazards would have been worse because of climate change. Climate change will fundamentally make the impact of some of these hazards worse. And here are some photos, pictures of some of these hazards I mentioned. This is on the top left, the tsunami on the coast. In the central top central is a sort of a video which I don't have time to show now of a dam burst that led to flooding and it flooded this entire Syrian village. And the bottom left is that flood I mentioned that killed 20 people. And then the bottom here again, that's the hailstorm. That's not snow, that's hail. And there were other humanitarian stuff such as fires in some of these camps. So overall, quite a significant multi-hazard scenario event. But more academically is when does it end? When do you say? So I framed all of this as a big multi-hazard cascade, but when has it ended? When does it end? And how do you split out this cascade into mini sort of multi-hazard event sets? I mean, could that be one multi-hazard event set, or is that a more multi-hazard event? And is it time split? So a week later, the storm and the flood, is that another multi-hazard event? And then the following week after that, another event, and so on. And and I don't know the answer to this. We haven't, as a community, come to terms or come to a sort of a generalization of how and when multi-hazard cascades end. And one determinant could be vulnerability. If you look at the pre-earthquake vulnerability, and when the vulnerability has recovered to that level, should that be when the multi-hazard cascade ends? I don't know if that's the case or not, and how you would measure that. And it remains one of the big sort of academic exercises we haven't decided on yet. So to summarize, this is my cartoon of all of these processes at work. Think of a big city on the coast, Jakarta, Hanoi, any other big city, and then you have a big earthquake. And then you drop cover hold on that table, and the shaking stops, and you run outside, right? Everyone should do that. And when you're on the coast and you feel a big earthquake, you run outside and what do? You run uphill as fast as you can because you've got 15 minutes because a tsunami was coming on its way. So this man did the right thing. Held onto the table, ran outside, and ran uphill. And 20 minutes later, tsunami arrived. What about this person? The person in the wheelchair. In the Izmir earthquake in 2020, I think it was, in Western Turkey, one person died in that event, and it was a woman in a wheelchair. She didn't die from the earthquake. She died because she couldn't wheel herself quickly enough away from the tsunami. And it was a small tsunami at the time. What about these people? People with families, elderly people, pregnant women. Their vulnerabilities now are uniquely different to the tsunami than the healthy man who ran uphill. That man up on the hill, sat on the hill, when it starts raining, parts of those hills are going to come down. So his exposure to landslides is now very different to the other people. So the risk becomes extremely localized and unique to individuals in these multi-hazard scenarios. And this is a very simple cascade. So I'm trying to get at is that changes in exposure and vulnerability during a multi-hazard scenario means the risk evolves over time too. And the risk becomes highly individualized. So we need to rethink this age-old risk equation. So this is how a lot of organizations do it, including the World Bank and others, to measure risk. They take the hazard, multiply that with the exposure, and then multiply that with the vulnerability, and that gives you a sort of a measure of risk. And by this talk now, by now, you should know that there's the big element missing here, time, because risk evolves over time, and all of these are functions of each other. So really, it should be something like this: the hazard and exposure interact, the hazard and vulnerabilities interact, the exposures and vulnerabilities interact. All of these interact with each other and in time, which means all of these variables go up and down in time, which means the disaster risk evolves over time too. And I've had to draw this like this because I simply don't have the mathematical ability to turn all of that into proper analytical solution. For now, we're stuck with this sort of analytical approach to non-analytical approach to understanding dynamic disaster risks. And I think this is my last slide. And so I've talked a lot about doom and gloom stuff, lots of death and disasters, I'm afraid. But it's all of that death and disaster falls in this context, right? There's been a dramatic reduction in the number of lives that have been lost to disasters around the world. In 1920, nearly 500,000 people every year were dying in one sort of disaster or another, natural hazard disaster. Now it's around 40,000. This dramatic drop has happened in the last century, mostly because we've been very good at managing vulnerabilities to floods and droughts. So we've shown how we can reduce vulnerabilities to two of these big killers. And I firmly believe we can do the same for the others. Earthquakes have been notoriously difficult. And you can see this pale green color here. There are big bumps where enormous losses happen, particularly in big events. And what's really worrying for me here is this red ones. The last 3 dates from 2000, this growing red zone are losses from climate related hazards, i.e. extreme temperature. And that's growing, and that's very concerning. But we can reduce these losses. We've shown we can do it for floods. We've shown we can do it for droughts. We can do it for the other hazards too. And so to summarize, the 2023 earthquakes are a tragic reminder of how poor preparedness compounds with social and physical vulnerabilities and led to that devastating disaster that we saw. Disasters are fundamentally a human construct. We make disasters. If an earthquake happens in the middle of the Sahara Desert, it's not a disaster because there's no one there, there's no vulnerable people there. A disaster occurs when a hazard intersects with exposure, vulnerability, and corruption. Those are what make disasters. Vulnerabilities are spatially heterogeneous and temporally dynamic. They vary in space and time. And if you want to manage disaster, if you're a manager of risk, you not only need to understand the hazard, the geophysics, the thing that I do very well, we all do as academics, but also the social and built environments that people live in. Those two have to come together if you want to manage disaster risk properly. And disaster response, if you're a responder, a manager of those types of risks, you need to understand the dynamic nature of multi hazards and that the risk evolves over time as well. And a warming world will exacerbate vulnerabilities to many of these natural hazards that I spoke about today. So that's it. I'll end it there, and I'll take any questions. Thank you.
Thank you so much, Ekbal. This is a very entertaining presentation, I think, in terms of. I like the way that you really illustrate what you're trying to show us, particularly. So I think that is very interesting. I would like to open the floor to questions in the Q&A. I think you can type questions in the Q&A, please. So I'll give people a few minutes to do that. I have a couple of questions myself, and I don't know if also our postdocs have some questions. If you do, let me know, because you might want to ask them as well. Yeah. I really like how you show why you kind of simplify why hazards become disasters, and there's some things in there that I think you could, I mean, I would like to unpick them a little bit more even. And one of the things is around, I really like the cascading, how you talked about the different cascading disasters and how those become more unique and highly individualized over time. That was something like, for example, in COVID that I noticed, if you look at the way that COVID impacts on people, it's so different. I mean, you can say, of course, general things like, of course, if you miss education, this is going to impact on your life in different ways. But the ways that actually does is so different by different people. And one of the things that I've noticed noticed in my research is that actually the decisions we make about how we recover from disasters also has a big impact on those kind of things. I've just wondered if you had considered that. So it's not just like the hazards that happen, but also, like, for example, as you said, if you're living in a tent, you might be more exposed to certain things, or, for example, the way that the debris clearance was done in Turkey and how this exposed different people to different things, or the long-term impacts of living in container cities without the certainty of where you might go later because of land being taken and things like that. So I was wondering how you might fit those into your model.
Absolutely, and I think I guess it's quite, I don't have a model as such, more of a conceptual idea, but I think absolutely right. So decisions, this all of these are about decisions, and all of these are about how decisions are made by ourselves as individuals, but decisions made for us by others. So, for example, after that Turkey earthquake, I had a phone call from a small charity who went out there and rescued orphans, newly orphaned children in that event. And I got a phone call, and he said, "I've got 60 young kids. Here's a photo. Where do I put the tent to put them?" And that's a decision that has to be made, because you can't not put them in a tent at that time. And those are really difficult decisions, because I've never been to that part of Turkey. All you can say is some really high sort of basics. So, okay, don't stay next to a building, don't next to a hill that could collapse, or not next to a river that could flood. But ultimately, that's a decision someone's going to have to make. And it's not being made by those children, it's made by someone else for them. And if that tent's put in the wrong place, it changes their exposure to what could come next, i.e. a flood or a landslide. So that's more local decision. The bigger decision, as you said before, around where you move stuff. So, once you have one of these big earthquakes, you create a mountain of rubbish, concrete, steel, all of that rubbish. That needs to be put somewhere, moved somewhere. And where you move that changes the local community's exposure to particular hazards. A good example is, I think they're on the order of 150,000 cars in that rubbish pile, and 150,000 batteries in cars, which leaks into the environment that cause an environmental hazard. Environmental toxicity becomes a problem. So decisions around those become part of your multi-hazard scenario. And so, and that complicates these things in quite a dramatic way. And I tried to show a quite simple process of earthquake, landslide, flood, earthquake, tsunami, landslide. And it gets quite complicated even using those three. And getting other hazards in and decision processes makes it more difficult. And I don't know yet how we incorporate all the decision-making elements into this conceptual model. And as you can imagine, the decision tree becomes extremely long and large. But if you do the what if, you had made that decision versus this decision. What if the manager of the UN OCHA had moved the camp here instead of there? And I'm not fully. I don't think I fully grasped how complicated, how quickly it becomes more complicated in that environment. But yeah, I completely agree.
Yeah, I think we need more research on that area. Yeah. Definitely. Yeah, I saw someone raise their hand, but I'm not sure how to bring them in. If anyone knows that, please go ahead and open that.
I think there's a Q&A as well, I think. Oh. Training drills at various levels of society.
Yeah, so there's a question from Gary de la Promare. Oh, wow. Nice to see you, Gary. My says his Wi-Fi in Kathmandu is inconsistent. Might you have you might have mentioned, can you discuss how you see training drills at various layers of society affects vulnerability? Yeah.
Gary, I think you know the answer to this. I would always advocate for more training. Training is not about so I saw this wonderful video recently, actually, about in a school where there was an earthquake, and the kids basically did exactly what they should do. Rapidly got onto that table, and onto the table, and when that happens, it's not about deciding to do it. It's an automatic reaction to do it. There's no decision time. You just do it, and I think that's the importance of training. It's the sort of muscle memory. A friend of mine has a wonderful story. She was in Japan at the time with a whole load of professors in an earthquake hazard meeting when that Japan earthquake happened, the Tokyo earthquake happened. And these are all preeminent professors of earthquake hazard science. And what did they all do? They ran like headless chicken. She was the only one that hid under the table because her child had hid under the table. And she wasn't going to leave her child behind. And so it's quite interesting. It's not about knowing what to do. It's about reacting and doing it. And I think training is one of the most fundamental way to do it. It's particularly young kids. They will just react and not think about what the other consequences are. Obviously, training is not just about that. The training is all about the other parts of building a society that is able to respond and able to react and able to be resilient. I think that fundamentally helps build our resilience, the inverse of vulnerability in many ways. If you're able to have that coping capacity in our society, in our communities, that can only make us more resilient. And training does allow that and enable that.
Good, thank you. I'm just trying to read some of the questions here and sort of bring some questions out. There's a couple of questions about, so we understand the origin and nature of disasters and the mechanics of their cascading effects. How do we make our communities and infrastructures more resilient based on this? And another says, we understand all these homes have been legalized in Turkey, and poor decision making and utter defiance of building codes is leading to hazards and huge disasters, as you point out. And also, I think related to the question above around how we make infrastructure and communities more resilient, how can adherence to strict rules imposed through community participation be initiated? So they're interested in the role of community participation.
It's quite interesting, as you quite rightly points out with these questions. It's the infrastructure and the buildings, the physical infrastructure in an earthquake is actually the biggest determinant of your losses in an earthquake. And if we split it out a little bit to the sort of homes first,
Mhm.
homes, Seth Rostein has done quite a bit of work on this in the USA, showing how actually very simple tweaks in how you build homes can make it a little bit more resilient to a moderate earthquake. Okay, maybe not a magnitude 9, but you'll probably save you from magnitude 7 or 6.5. And so little inexpensive tweaks can make homes quite resilient. And they've calculated something like it costs around 10% more. So it's not a huge expense to build a home fairly resilient, to be fairly resilient. Not, not it's not going to have springs and stuff on it, but you can have little engineering tricks, like not cutting the rebar rods off in the corners and bending them in, kind of. Imagine the rebar rods going up on the pillar and the rebar rods going across. I know most people what they do, they chop off the ends and just cement around. If you just bend them in a little bit, it gives you a really strong corner, right? That doesn't take more rebar or more cement. It just takes a little bit of know-how. So it's not an expensive trick, and it's not going to save your house if there's an magnitude 9 or 8 point whatever, but it'll probably save that from a moderate earthquake. So what they're trying to do, and what we're trying to sort of in these poorest parts of the world, particularly with experiments in Nepal, is applying these very basic masonry tricks and then training masons to apply them. And very simple tricks like that and many other engineerings you can add that make your house a little bit more resilient than if you just built it by yourself with no sort of knowledge. So that's one way of trying to do this. Obviously, the gold standard, if you all had springs and sliders and all of that, but that costs money. That costs a lot of money. And unfortunately, those of you who respond to the UK National Security Risk Assessment exercise every few years, this ultimately is a cost benefits problem. Things that cost versus lives that will be lost. And there's a sort of middle ground you have to get to. And that cost benefit calculation becomes a unique bit wherever you live in the world. For the bigger infrastructure design, and I think this is actually not. Actually, I don't think this is a big problem because the regulations are all there. Okay, the earthquake regulation is not designed to stop you from a windstorm, but most of the time it does the same. It does the job. It's a minor tweak to stop the earthquake and the windstorm in one go. It's when you start thinking about earthquakes and floods and earthquakes and landslides, and these are all we can design engineering standards that respond to a multiple of hazards, which is what they tend to do anyway. It's just making that multiple encompassing all the possible hazards that could happen in that area. And I'm a huge believer of the engineering community. Give them a problem and a parameter space, and they'll design solutions to it. It's us geophysicists who haven't told them what parameter space to be working within yet. And I think that's where the sort of engagement can be better. But it's not an unsolvable problem in my mind.
Yeah. Good. Yeah, I mean, I think that you mentioned, for example, the graph you have on corruption, and some that are more corrupt and some that are less corrupt than what would be expected. And I guess the question is, and maybe pushing you a bit more on that, is, what if partly it's corrupt. Okay, there's systems that are not working properly for different reasons. What do you think, or do you know what has been done? Those ones that are sort of above the line, but yet in lower income countries. What are the kinds of things that they've done to be above the line?
It's a great question, and I think it's a difficult one to answer because sometimes you can't disentangle corruption from other things like poverty and things like that. And in general, the least corrupt nations in the world tend to be the wealthiest nations in the world, generally. So very simply, you could say, to tackle corruption, you tackle GDP. Obviously, that's a very simplification and not what I would say. But in general, that's what that graph would show you. Simple assumption. But I think more fundamentally, what it says is the strength of institutions. The least most corrupt countries in the world and the ones who are anomalously less corrupt based on their national income levels have strong institutions. They all tend to have bodies that manage independently of financial and or government bureaucracy. Things like inspections, things like audits, things like routine surveillance, these are all about strength and trust in institutions. The challenge is that takes resources to keep those institutions going and funded and supported. And you'll see there's a concerning trend in some nations, particularly some that I work in, of these original bodies that were sent as anti-corruption departments slowly being withered away and defunded. I think that for me is a way to start thinking about this. Is how do we strengthen our institutions? How do we trust them? How do we strengthen the legal procedures? And fundamentally, it's also about how we finance them, how we pay our lawyers, how we pay our inspectors, how we pay our auditors a living wage so that they don't need to use corrupt means to make their livings. But that's more of the petty type of corruption. The more institutional corruption is, I think, is another element that I think we can do and we should do, and we need to prioritize.
Mm-hmm. Good. I think there's a couple of related questions here. Okay, I'll go on the last comment. Richard Hughes says most training and results in poor countries last a short time as forgotten people move on or out or pass away. Your bending of rebar has been recommended and trained, but still not applied in the Himalayas despite training rules.
Yeah, I think it's about. Okay, so apparently the lights are going to go out. So if I go dark, you know why. So about training. So yes, it's not. So for me, it's when I say training, I don't mean the sort of tick box. I've done my training, or particularly people like me who go to overseas and do a training. Is I've ticked the box, I've done it. It's about institutionalizing it. It's about realizing that this is something that they take ownership of. So one great school in Indonesia that I'm working with is the head teacher of the school realized that they live on a fault, and so every week they do a training drill. Every week, it didn't have to come to me, it didn't have to do anyone. The teacher just realized that's something they need to do, and they make it part of their PE exercise, their physical education exercise. All the kids running around with books on their heads. It's part of their physical education. So it's about making it part of their routine, day-to-day life. So that's where training, I think, it's not about the sort of performative type of training. It has to be part of and embedded in part of the reality of what they're working on. Same with the training of the masons. Again, it's I mean, I wasn't involved in the masonry training, but it's about making it part of their day-to-day life. It's not about, oh, I'm going to go here and tick box and therefore put a certificate and say, look at me, I've done a training with a Western NGO, and therefore you can employ me to build your home. It's about really embedding the reasons why and what behind it. And often I find I've worked a lot in Indonesia, so I can learn talk about Indonesia, is working with communities who have recently had an experience of an event. It's more in their mind about what resilience means to them, or that family members who are experiencing it, who are in an event. It's that really localizing and contextualizing what this training is for and why it's necessary. And I found taking those people to other places, from one part of Indonesia to another part of Indonesia, and making resilience a human narrative. It's not about engineering solutions. It's about human people. It's about people understanding what resilience means in a social context. And engineering solutions are technological, techie fixes to things. The reasons are always a people thing.
Yeah, good point. Then Alasani raises the point that when we were talking about impact and the different impacts that come, she says, if I may add to the impact, destruction of housing and properties and losing people's papers and documentation to prove ownership to be compensated. In Syria, there are many issues in the real estate system and land registry for many reasons. It's very outdated, challenging for displaced people and impacted people to prove their ownership of properties if they're lost as a result of earthquake destruction. Then the long-term mental health issues faced and by affected people, even after 3 years, remains a challenge. From the earthquake in Syria, racism in Turkey against Syrians who are both there at the moment and affected by the earthquake led to many challenges in such a difficult situation, she finds. Yeah. So I don't know. You don't have to comment on that. I think
No, I
making the
think it's a really
comment,
important
but
point
yeah.
that, I've talked a lot about the high level stuff like physical buildings, vulnerability of poverty, etc. But the nuance of details are important, and I think is it Allah has raised a really important point.
Yeah.
Actually, those who have survived need to live, and they need to live and move on somehow. And moving on is not about rebuilding their lives; it's about proving that they exist. Sometimes, proving that they are who they are. Their homes are over there, and I think that's a really important point. And I don't know of any good examples of how that can be done better. Um, in some communities, the communities completely destroyed, so they get completely relocated. So every individual gets given a new house, regardless of if they owned one or not before. And in many ways, that's easier. So some of my colleagues in Indonesia, they just decided to move an entire village, and every person got the same house, regardless of if they had a four-story house before versus a one-story house before. Everyone got a two-story house. So that's in many ways a simple solution. Not in There are other social issues around moving an entire community, but in engineering wise, that's a simple solution. But the problem remains of identity and the sense of purpose that you might
Yeah.
need following a disaster.
Mm.
And again, this is where my experience really falls short, and I need help with you guys to understand this better. What could be a good solution? How can we design a good intervention? Of one could be digital ID cards, right? And there's a big sort of furor at the moment in the UK about digital ID cards, but digital identities do help, right? You don't need to have physical papers anymore. And if you lose your house or your passport, you have a digital version somewhere that can verify who you are and the
Mm.
fact that you own that space, that house. I'm not saying that's the only solution, but that could be one way of dealing this, particularly now in this technological world that we live in. Maybe our record of our lives can be kept and recovered in the event of a disaster.
Hmm. I think I had a lecture yesterday with my students who were talking about putting people at the center of recovery. So there's a very nice writings from the Asian Coalition for Housing Rights where they talk about how working with people about people's priorities at the center, which is essentially what you're
Mm-hmm.
saying, I think. Um, Another question. I think we've gone around the many cycles of modeling of hazards, vulnerability, and resilience. In my work in the Himalayas over 40 years, I've been saying the same thing about improvements to traditional housing, but little happens. Surely the key concern continues to be willingness to spend money related to
Yeah.
personal, political, and societal priorities.
Yeah. Yeah, that's obvious. Yes, of course. There are two parts of this. The first part, as I said earlier before, some resilience measures doesn't have to be expensive. We can do some very quick wins with the low-hanging fruits. The bigger thing about resilience and the cost of resilience is, you're right, this costs money. If you want a truly resilient society, you need to spend money to build a truly resilient society. But that's spending money is a luxury of the rich, I'm afraid. Um, Japan, there's a reason why in California the big 1994 earthquake cost something of the order of $10 billion. I think these are numbers I pulled in my head. I think it's around $10 billion, which equates to something like $40 per person or something like that who lived in California. So, and something on the order of I don't remember how many lives were lost in that. So 80 odd lives were lost. So we can work out the dollar per life. In Haiti, $14 billion again, 100% of its GDP. So now you can work out the dollar per life. California can afford to pay to build its resilience. Haiti could not afford to pay to build its resilience. So total resilience is the luxury of the rich. So the question we have today is, how do we prioritize good enough resilience that's within the sort of the priority scheme of any developing nation that we work in? And this is where, again, I can only speak about Indonesia. The challenges I have, you go to a minister and say, look, you have an earthquake problem. And they say, no, I've got an education problem. And I said, you've got an earthquake and an education problem. So tell me, how do I prioritize which one? Do I spend money educating my children, or do I spend money building the home safely? And this, again, has to be part of a prioritization exercise. It has to be embedded into all of these spaces. You can educate children in safe environments, right? So you can do both. And it's for us to identify where the intersections lie, and where, okay, I'm not going to make my society 100% resilient, but also don't want nobody to go to school. So what's the intersection that I can work on that builds all of us together in the right direction? And I think again, but it's going to be expensive than any one of those solutions. And I don't know if there's the right way to do it. And I suspect in any community you go into, any minister you talk to, there'll be a different approach and different spending budget, there's a bit different sort of priority list. And it's about how to embed resilience as a priority amongst all the other things that a nation has to prioritize. And also us about being humble, about actually earthquakes kill a lot of people, but measles kills more. Earthquakes kill a lot of people, but diarrhea kills more. And so, if I was going to Ethiopia or somewhere that has an endemic issue with some of these health issues, I probably want to prioritize that before building the earthquake resilience, or do it in a way that can do both in a good way.
Great. We have a question from America Bendito. I'm going to unmute you if you'd like to tell your Zaishang, if you can do that, if you'd like to give your question. And also, Zaishang, Richard Hughes and Ala Asani, I think they all had some questions. William Turno.
Are you able? Who? Sorry.
Are you able to unmute them?
Yes. So who should be the first one? I can unmute.
You can unmute them all, maybe, and see. I don't know who's there now. Yeah.
Okay. Let me find it.
So I'll just go to America Bendito. I find your breakdown of exposure, vulnerability, corruption, ignorance very compelling, especially the point about incremental housing improvements, increasing seismic vulnerability. Would you consider these drivers as outcomes of deeper risk governance conditions? I think you've discussed that somewhat. For example, regulatory enforcement, land use planning authority, accountability chains, incentive structures often determine whether unsafe materials, inappropriate zoning, or maladaptive retrofits occur in the first place. Referring to the IPCC AR6, explicitly recognizes response as part of the risk system. What remains undeveloped is how governance, authority, and decision-making capacity shape those capacities. America, do you want to add anything there?
I'll just wait for America. There we go.
Yeah.
No, you read it perfectly. My idea was the first like a question, and the second one was just to add that you were talking about the hazard, that risk is hazard, vulnerability, and exposure. And one thing that for me has been really emotional in some places that the IPC now is recognizing response as part of the risk. So it's now we can not see it just endeavoured inside vulnerability or exposure. It's like an external point, no, that you really put in response as a driver, as a really part of the risk, no, with maladaptation, where governance is part of that, no. So the second part was more like saying that now we have hope to say it in the risk equation, and the first was a question. Thank you very much, and very wonderful presentation, enlightening and very good presented. Thank you very much.
Thank you, Emeka. It's very kind of you. Yes, of course, you're right. And this is also embedded in the Sendai framework on Build Back Better, in this Build Back Better mantra. You can't stop hazards, and sadly, you can't stop some disasters, but you can stop them reoccurring by building back in a better way. And that's sort of embedded in that, I think, task 4 of the Sendai framework. And I think that is part of that. The response is unfortunately a reality, and it has to be done safely and sustainably, but can be done with a long-term vision in mind. And I think embedding that Build Back Better mantra more systematically can really help build our resilience. But sadly, the caveat to all of that is, sadly, it's not always there. And it's not always possible, given the timeliness and the timelines and the resource needs to build back data and the decision making that we need to make. So sometimes decisions need to get made, And regardless of whether you've got the Build Back Better procedures in place or not, that village is being moved because there's a landslide coming or a volcano is erupting or whatever's happened. They need to be moved. And there's simply not time or resources or headspace to think about what the better approach could be. And other times, the urban planning space bit that you said, and wouldn't it be wonderful if our urban centres could grow in planned and organised and sustainable ways, and that would be amazing, wouldn't it? If we could, but if you go to Jakarta and try and say grow your 42 million people city in this sort of systematically planned way, it's not possible. Urban centres are organic. Those who do urban studies know that cities are organic beasts. They behave like amoebas. And it's unplanned and unregulated sometimes, and adding structure to that is something we want to do. But maybe for us as hazard scientists, as resilient scientists, need to stop trying to stop the amoeba growing and control the growth of the amoeba, but to embrace the growth and to decide, take that as an axiom, the city is going to grow. It's probably going to grow in an uncontrolled way. But how to enable resilience to be embedded as part of that growth anyway, regardless of how it's growing? So if it's going to cross a river, regardless of what you do about the city, how do you make that flood resilient, that growth flood resilient? How do we embed resilience as part of that organic growth? And I think urban planning and urban design and urban science can really help us here understand how can you build things. So one of the things that we work on in Southeast Asia is how do we embed sustainable urban drainage systems as part of the natural growth of a city, regardless of how it's growing and why it's growing. Just green space growth and green space urban drainage systems as part of a natural feature of growth. And how do you reframe the growth narrative as that, rather than just taking up lots of space to grow more buildings? But I don't know if that's the solution. But I'm conscious that we try to control something that's, I think, hard to control. So I embrace the fact that it's going to grow and try and build a resilience in it as it's growing. But again, that's a very vague answer to a quite complicated question. I don't know the correct answer to it, but that's my hunch and that's my intuition of where I think it should be.
Thank you. William Turno had a question. Based on your experience, what would be the ideal time for updating the hazard maps, vulnerability maps, and risk maps? This will help in analyzing cascading hazards.
I can tell you what my ideal time is, and I can tell you what the reality is. And the ideal time is now, or yesterday. And, as we're learning more, this multi-hazard space is really growing in the last 10, 15 years or so. The research is now pretty significant volume of research showing how cascades work, how cascades affect vulnerability, how vulnerability cascades with time. So there's quite some research now. And so, the regulations can start already adapting to this, and we can start building in measures that take into account that's my light gone. These multi-hazard cascades. Sadly, the reality is building codes and regulations evolve after a disaster has happened already. So if you follow the building code designed for Turkey is a really great example because it's updated its code quite a few times over the years. And every time it's updated, it's usually following a major earthquake. And so you could think of that as almost an opportunity space. If you're in the building code design, structural design business, sort of advocacy area, if there's a big earthquake in Turkey in 2023, the few months following that earthquake was your window to advocate for new designs codes, because that's when politicians are more receptible to change, and the public want the change in those moments. And as a political cycle, as geophysicists, we can't not be politicians as well, I'm afraid. The political cycle and the political whims, we have to conform to them or try and influence them. But the attention span of politicians is like a mosquito. You've got them for that one moment. And if you want to get your building code in, you've got to find that right moment to get it into their consciousness and therefore get it into action. So that's the reality. I would love to have continuous process. As we learn, we update. As we learn, we update. Wouldn't it wonderful to have a continuous learning code that evolves with our learning? But reality is it's always after an event, usually after an event, or some sort of political landslide.
Yeah. There's always that. There's somewhat of a moment. Depends on the disaster and the political context, doesn't it? I want to bring in Ala Asani. Do you want to speak? You can unmute your microphone if you want to give your question.
Yes,
you have a couple of questions hanging there.
Yeah, I know. I'm sorry, but I'm so excited when it comes to earthquake. I know it's heartbreaking and catastrophic memory, but I have worked on huge emergency the same after Syria earthquake response, and that's why I'm also my family and my friends and network all have been impacted of this. So I'm quite interested, not only personally but also professionally. So basically, thank you so much. Very informative, very comprehensive. I really liked and learned a lot about, everything that you have presented, especially from the engineering lens. I might maybe bring more social dimension here, and when we talk about, vulnerability, and especially for the ones who receive less attention in earthquake, as you know, it's impact everyone regardless nationality, backgrounds, and they usually, we expect, such disaster to produce social solidarity, but in some context where there's lots of racism, it produces more fragmentation and damaging the social cohesion. I'm bringing this because it's very important witness. I'm working on another research paper with UNESCO, and it happened that I was talking to one of the displaced women in Turkey, and she mentioned that she's still being traumatized from the earthquake. She took strategic decision not to continue her PhD to travel abroad because she feels responsible to stand with her mother because her mother cannot stay alone after the earthquake. She also mentioned that every day she switched on all series that she used to watch back home in Syria 10 years ago, just to feel she's unable to sleep without switching that on. Otherwise, she won't feel safe and home. And also she mentioned some of examples at the night of earthquake when they tried to support each other with the neighbors and everyone. Like, she was stopped by a lady. She was super angry because of the earthquake. She told her, she knew she was Syrian. She told her, "You Syrians, I wish you all to die." So it was quite hurtful for her, but also for me to hear this, and I'm shaking while I'm saying this, because it's not about only, the destruction, the physical destruction, but this literally can also bring emotional destruction to such people who are both in the same disaster. So I think it's important, just when we think about the DRR frameworks, how best we can integrate social cohesion, and we tried, and not only in on earthquake, even like in the normal situation, and then because easily this can be triggered and be worse. So that's somehow I'm trying to understand how such, approaches and frameworks can be framed in a way that it is better anticipating and mitigating those social aftershocks in terms of discrimination, exclusion, and how that also influencing the government, the communities, and aid agencies when they intervene in such responses. Like I recall also she mentioned lots of spaces has been opened up at the night of the earthquake. So it was they said not only for Turkish and Syrian who left exactly what you said in the streets under the snow and under the rain. So, and that was just at the moment where only in this moment if we need to stand together, maybe, at least So, and also my other question about the destruction. So you mentioned about, I think, legal or illegal corruption. And I like that terminology. So you mentioned, from my understanding, also in Hatay, we have seen lots of destruction, especially in newly built luxury buildings, not only informal settlements or slums, but I kept wondering how this has collapsed completely. And I don't know if any post-investigation happened in the earthquake, just to understand, was it as a result of this corruption? Was it because there were no proper codes has been followed to protect and to secure, any potential future earthquake? So that's another question. And lastly, I think it's also, as I said, it's disaster for everyone. Maybe another, just for me mentioning this example to highlight how the compounded challenges are different from context to another. So this earthquake hit Syria and Turkey. And Syria, in the context of there's sanctioned government and red line area where it's besieged, like you only can access it through cross border, and they only allow specific agreed type of support. So in such areas where around 6 million are displaced only around the borders in the north of Syria. So those lives in the tents who have been impacted by earthquake, already impacted by the conflict, and the ones who have also been living in housing, and those housing has been damaged, I mean, partially or completely. My question here, who compensate those questions if there's fragmentation in the governance? While in Turkey, which also catastrophe situation, but also I know the Turkish government have done initial assessment to the houses and have compensated the people to do initial, measurements to address any damage. So they gave them, let's say, payment to do this. So how such measures then, in a context where there's a conflict and lack of governance, and how it's also create further damages and challenges for those people. So I'm just bringing here the level of complexity and challenges that are faced by maybe not the same people, but in the same region with the same earthquake that we sometimes don't speak about. Thank you.
Wow.
Yeah.
Thank you, Ala.
Yeah. A lot of different complexities there,
Yeah.
which I don't know if you have answer to some of
I think
those things.
I think you raised some really important points. Thank you, Ala, so much. I think clearly you're sort of well embedded in this, and you arguably know better than me now the details of this. But I think you have three main questions: one around social cohesion, one around sort of corruption in Hatay, and others around the sort of the novel, new, well-built, luxury accommodations. Another one, the governance in Syria. So if I start with the first one, social cohesion, I think so. This is quite a complex and complicated space, and I think a really interesting space. The issues of cohesion following immediate disaster. Our research that we've done in the past, those with John Drury, who's a professor of psychology, of crowd psychology in, I think, Coventry University, or Sussex University, sorry. It's interesting. So I find this fascinating, this how crowds behave, the psychology of crowds. Because think in an immediate shock, you're now a crowd in an earthquake. And what we've shown, and John has shown quite nicely, is that in those immediate aftermaths of, in general, helping behavior goes up. The Hollywood idea that there's a stampede, everyone fights for themselves, doesn't bear witness. The evidence doesn't bear witness to that. Almost always, crowds who are in an event share what we call a shared fate situation. They become part of the same tribe. But that only works in those immediate aftermaths. So the helping evidence of helping and strangers goes up. So we saw this not only in the Chile earthquake, the Maui earthquake, but also the July 7 bombings in London tube station. It's a disaster, two very different types of disasters, but an event, usually instantaneous one, that puts what we would call a stranger group into now a shared fate. And we are now part of the same tribe, and tribes help each other. In those immediate aftermaths, you get to see that. However, what you're seeing, and I think quite rightly, showcases actually those tribes don't live long. Those tribes don't survive. The existence of my group dissipates very quickly. And even hours later, now the sort of issues of social cohesion falls apart. You're not my person, you're not my person, you're a different ethnicity, you're a different race, you're a different gender. All of these issues start coming into play and then start becoming quite more problematic. And as you said quite sort of powerfully with your person you spoke to, they lead to really dramatic consequences. And so the question I would have is, or the solution is, how do we engender the tribe that behavior to continue, the helping behavior to continue? Can we design social nudges that enable that to happen more? And this is where behavioral science can really help us. Can we work with psychologists and behavioral scientists to design our camps, our sort of immediate relief zones, to engender this feeling of you're part of my same group. You are now psychologically the same group of people, regardless of my gender, ethnicity. And this is where I think geophysicists need to be working with psychologists, behavioral scientists, and to not sort of make things worse by saying, oh, you're part of this tribe, you sit there, you're part of another tribe, you go here, and already creates a position of us versus them. And quite clearly in your example as well, there's a lot of PTSD, which is another big impact of hazards, and there's a long-term consequence on social welfare, social well-being that needs to be addressed. That should be part of our recovery plan. How do you support people to move on, not just in the immediate aftermath, but the years following, and help them rebuild their lives in the best way possible? And the second question on Hatay and sort of the sort of rich sort of buildings, yes, sounds like they weren't built very well, and I think that's probably almost certainly due to corruption. But it's not all corruption. Some buildings will just fall, partly because of the ground they're on, the sort of soil conditions that they're under the building. But all of those should have been taken into account as part of the building code's assessment. So it sounds to me they just weren't following any of those rules. And the last one was governance in Syria. Yes, I understand totally. The level of vulnerability just on either side of the border were dramatically different. And the Syrian vulnerabilities were extremely acute versus the Turkish, even though the shaking was higher in Turkey. And this again goes back to the institutions. In Turkey, there's quite a good institution to manage disaster risk and disaster response, AFAD, and it's well supported, well financed. Despite its mistakes and lessons learned, it's very responsive and very good at responding and dealing with emergencies. In Turkey, 10, 15 years of war have sort of destroyed all of those institutions. Sorry, in Syria, destroyed all of those institutions. And it's not a surprise that the response was lacking and the support was missing and the sort of the Build Back Better wasn't really in place. And I think, and this hopefully is a lesson learned that these matter. And as Syria is rebuilding itself, it starts rebuilding these institutions and supporting them and enabling them to do their job. In the context of, no one's got any money in Syria, and how do you support them? The international community has to really help. The international finances, disaster risk finances, have to start playing a role here.
Mm-hmm. Okay, thank you. We have another question from Sena Gunashkaya, who's asking. I think she can actually speak here too if she wants, but. Essentially, she's saying that she's asking about these safe existing buildings that we have. Mm-hmm. And for example, in Istanbul,
yes,
literally thousands and thousands of buildings that are very high risk and across many countries, including across Turkey. So she's asking about that, saying that these zoning amnesties was a way this was a way to kind of, I guess, address that.
Yes.
So, yeah. Do you want to ask your question, Sena? Were you just making a point, or do you have a question you want to ask there? I don't know if she's coming online.
I can comment on that, Sena.
What to do about all these buildings? That's a big question. I don't know if
building stock, legacy building stock is a big problem, right? You can have a really good code now and keep all your newer buildings safe. But what do you do about the millions of buildings that were built in the past, and how do you protect those? And so this, I think, is coming to that problem, right? So, and Istanbul is a really good example of this, because I think 2012 they started, writing this law called zoning amnesty, and it's come into play in the following years. And the idea was originally it was designed for all buildings, and eventually it went on to just public government-owned buildings. That they'd do a survey, and if it wasn't built well, they'd destroy it. The challenge with those laws, which sounds like a great thing, and I think it should be good, and that's great. But there wasn't any provisions put in place on who's going to build it afterwards, and who's going to, if you destroyed it, it's fine. You're going to build it, rebuild it, and who's going to pay for it? And so, in many ways, that law was half done. The first part was great, identify where there's vulnerabilities, structural vulnerabilities, and the second part should have been about how do you rebuild it after you've took it down. And then it wasn't implemented systematically and throughout the city. And why that's the case, I couldn't comment, but I suspect there was some politics involved in all of this and some economics involved. The mayor of Istanbul is a different political persuasion to the government, and I suspect some of that's helped, some that hasn't helped. But the broader picture remains in that there's a whole legacy building stock, and that's the same with every major city in the world. Tehran is a really good example of this. There's a huge building stock that's extremely vulnerable, and Tehran is one of those cities that we've been looking at, keeping our eye on for that million death potential because of that legacy stock. And it's extremely expensive to retrofit them. Retrofitting all of those buildings is going to be extremely expensive. And I don't know what the solution is to this. You could go the Chile approach and just let them collapse in an event and rebuild them back better. or we could start actually financing the sort of retrofitting and the resilience measures. And maybe it's not about making them all on springs, but can we do that 10% approach, make them a little bit more resilient? And so, okay, they won't collapse and kill everyone, but they might crack and break, and therefore they'll need to be rebuilt in an earthquake anyway. But the cracking and sort of adding failure spaces in is probably a middle ground that can be done.
Mm-hmm. Yeah, I think that when I was in Turkey for the EFIT mission, we saw some very interesting examples of apartment buildings that had been retrofitted with shear walls, for example, that managed to stay up. Mm-hmm. But I mean, I'm not an engineer. I don't understand why this isn't something that's like widely applied instead of, as a kind of band-aid instead of leaving things how they are. Mm-hmm. I'm not sure. We had another question, and maybe I think is our last question, because I think we've managed to look at a lot of them. And the questions from Yoser Cruz, natural, which I want to kind of leave on a positive note. If you want to think of some things, natural emergencies bring disaster with them, no doubt, but also innovations to solve problems. And in your research, have you seen any innovations that you think have really caught your attention?
Oh, this is great. I think this is the way we should be thinking. I'm an optimist, so I fundamentally think we have the means and abilities to work through the problems. As the nature of research and the world is that you solve one problem, you create another. But I think we can and we should, and we are able to move that way. A really nice example I saw recently was again in Indonesia, where they have a persistent flood problem. And the National Disaster Management Agency, it's a country of 17,000 islands, 11,000 populated at any one time. So a National Disaster Management Agency struggles to actually know there's a hazard and then respond to it. So the knowing part, where there's some really creative community solutions to this. So communities designing their own WhatsApp groups and sharing, oh, there's been a landslide here, don't go down along that road. Or social media, there's this really clever company that's taken social media information in real time and trying to map out the floods in real time and feeding that into the disaster management agencies, saying, oh, okay, the big floods, everyone knows about the big floods. The little ones that's affecting maybe one community or two communities. It's hard. They don't come up on the journalists aren't going there, but it's still affecting those local communities, and they're sharing it on social media. So companies, sort of flagging all of this up and mapping out where their events are happening, and getting to the impact of those events. And for me, the most important thing I'm seeing are communities coming together to build their own resilience in their own unique ways. That I think is the only sustainable way to do this. So communities in southern Java, once they realize that they have a tsunami problem, they're saying, okay, scientists, come tell us what the problem is, and we'll design our evacuation plan. We'll design how we're going to rebuild our homes. We'll design where the school should go, and we'll design where the evacuation paths should be, and we'll maintain it because we've designed it. And I think those are the most sort of the best and most inclusive ways to build resilience. And I think we're only going to do that more because those communities found out about the tsunami problem because we wrote a paper about it and it was in the news, and they read the newspaper. Then they got in touch with us saying, look, our village is on that coast. Come and tell us how about this. And we'll work and we'll design a solution to it. And I think as people have access to more information and more, hopefully, verified information, they can reach out and start thinking about their own resilience in their own unique ways.
Great. Well, thank you so much, Ekpal. I really appreciate your entertaining presentation and sort of the way you lay things out. I think it's very compelling. Makes a compelling argument for why we have disasters, I think, and points to some solutions about what we need to work on more to do it. And I think that our questions have highlighted the complexity of this in a lot of different scenarios. So thank you to everyone who's posed questions as well. I will just say thank you and sign off. I'm not sure what else I need to do.
Can I just say,
yeah,
I think the talk's recorded, so they'll be shared. If anyone, I think someone mentioned about the slides. These slides are open access and open source. So if anyone would like the slides, please feel free to email me and I can send them to you. And you can use them as you wish.
Okay, thank you very much. That's a generous offer. And yes, the recording will be posted online, so on the website. Great. Thank you to all our postdocs, also Zaisheng, Asana, Raphael, for all your efforts in organizing this. Can we get your email?
Shall I write it in the chat here? I'll try it in the chat.
You want to answer that?
There we go.
Great. Okay, thank you, everyone.
Thank you all. Thanks very much. Bye-bye.
Bye. Okay, great. I guess we're done. No. Yep. Okay, bye.